So I promised you that I would show you some different ways for how to write the second derivative and also explain what this is about. And I wonder if your brain has been ticking over as I've been working on this and you can see why we write it this way. Okay? Well, let's start with some simpler ways. Okay? We say the first derivative, another way to write it would be y dash, right? That's a way that you've seen it, okay? Or alternatively, you know, like f dash x, they all mean the same thing, okay? So therefore, when you come to the second derivative, number one, since a dash indicates differentiate, right? You sometimes see this as y double dash, right? Y double dash. This is very common. I still don't like it because it looks like, you know, to the power of 11, but, you know, whatever. You'll see the notation sometimes, okay? Or like, yeah, y. If that is your real name. Anyway, y double dash, okay? That's one way of seeing it. Or f double dash, I mean, it's exactly the same thing. Now, where does this come from? And how does it relate to this, okay? Well, let's think about how the first one came about. dy and dx, okay? Another way of saying it is, okay, I've got a function, sorry, I just want to not confuse this with the graph. I've got a function and it's called y. But we said to differentiate that is to stick a d on dx out the front, right? d on dx means differentiate, okay? Just like sin means take the sign of this value, okay? But you can see all we've done just for convenience is we've chucked the y at the top. So dy on dx, it's how y is changing as x is changing. Alright, now if we do it again, sorry, axis. If I take dy on dx, okay, the whole thing, and I differentiate that, okay, which is how we got this 6x, right? I would say d on dx of that, okay? Now do you see what's happening? It actually is a bit weird still as a way of notation, but the d's on the top, there are two of them, right? D and then another d. So that's why there's d squared, because you're doing it twice, okay? Whereas on the bottom, you've got the dx and then you've got another dx. So I suppose to be really technical, we should probably say that, right? Because it's really all of dx, you've got two of them, right? Hence dx squared, okay? Now people are lazy and they, I've almost never seen that written, like maybe once or twice, okay? So this is what they mean by second derivative. It comes from here, okay? Now just as before, I prefer this as your way of writing the second derivative, just like I prefer this as your way of writing the first derivative, because it carries meaning with it, right? This means rise over run. This means take the first derivative and differentiate again. Okay? And also later on, when you're not differentiating with respect to x, when you're differentiating with respect to other variables, with these ones here, you can't tell what you're differentiating with respect to. It could be x or theta or r or h or whatever. Okay? Whereas this actually tells you, so it's meaningful, right? I know it takes like a whole 1.5 seconds to write the extra characters, but I think they're 1.5 seconds that are worth it. Okay?
So can we write the brackets, like f bracket 2x?
Wait, wait, oh, wait, huh? You mean like this? Like that?
Yeah, like that.
You can. I mean, I think it's equivalent to this. I mean, the people write this to distinguish it from when you square a function. Okay, but to be honest, when you've got better ways to write it down,
you're writing like 100th derivative, that's going to take so much longer.
But you're not going to write 100th derivative. And even so, it'll just be 100 and 100. It's not so bad. Okay.
100 dashes.
I'm gonna put that back to 2.
Dashes.
Okay. So that's what the second derivative is. Okay.